Okay, check your understanding. This is chapter 10, lesson 1. Our words are condensation, which occurs when substance changes from gas to a liquid. Water vapor is the gaseous state of water. Gravity is a force that attracts all objects toward each other. This one is not in the PowerPoint, but it's on 224, right before the chapter begins. On page 326, that's where the chapter starts. We'll read the planet diary. It says, how much water do you use? You take a shower, you brush your teeth, you take a big drink after soccer practice. All day long you need water. How much water do you need to use in a day? How much do you think your whole state uses? The graph shows the water used per person in the 10 states of the United States with the largest populations. The data includes water used for all purposes, including farming, industry, and electric power. That's a lot. Michigan uses a lot. We're on there because we have a big population. So is California, Texas, and North Carolina. Florida's on there. We use a lot of water. All right, page 327. Why is water important? What do you and an apple have in common? You both consist mostly of water. Water makes up nearly 2/3 of your body's mass. The water is necessary to keep your body functioning. All living things need water in order to carry out their body processes. In addition, many living things live in water. Body processes. Without water, neither you nor an apple could survive. Water allows organisms to break down food, grow, reproduce, and use materials they need from their environment. Animals obtain water by drinking it or eating foods that contain water. Most animals cannot survive more than a few days without water. Same for humans. If we don't drink the water, we have to eat things that have water in them. Plants and other organisms that make their own food also need water. Algae and plants use water along with carbon dioxide and energy from the sun to make their own food. This process is called photosynthesis. Other organisms get food by eating plants or by eating organisms that eat plants. So habitats, where we live, water provides habitats for many living things. An organism's habitat is a place where it lives and obtains all the things it needs to survive. Some organisms cannot live without water. You are probably familiar with large water-dwelling organisms such as sharks, but most such organisms are microscopic. In fact, aquatic or water habitat contains more types of organisms than land does. So there's more animals in the land or in the water than on the land. Page 328, where is water found? When you turn on the tap, it might seem like an endless supply of fresh water comes out, but Earth's fresh water is very limited. Most of Earth's water supply, about 97%, is salt water found in oceans. I'm pretty sure this is one of the quiz questions. Only 3% of the water is fresh water. Of that 3%, about 2/3 is frozen in huge masses of ice near the North and South Poles. About 1/3 of the fresh water is near the North and South Pole. About 1/3 of the fresh water is underground. In tiny fractions of water, fresh water occurs in lakes and rivers. An even tinier fraction is found in the atmosphere, most of it in the form of invisible water vapor, the gaseous form of water, steam. Oceans, find the oceans on the map. Pacific, Atlantic, Indian, and Arctic are the names used for different parts of the ocean. Some scientists call the area around Antarctica the Southern Ocean, but the waters are usually interconnected, making one big ocean. The Pacific Ocean is the largest, covering an area greater than all the land on Earth. The Atlantic Ocean is next largest, though the Indian Ocean is deeper. The Arctic Ocean surrounds the North Pole. Smaller saltwater bodies are called seas. Ice. Much of Earth's freshwater is frozen in sheets of ice. Massive ice sheets cover most of Greenland and Antarctica. Icebergs are floating chunks of ice made up of fresh water that break off from ice sheets. You could also find icebergs in the Arctic Ocean and in the North Atlantic. There's a picture of a cup here. It's giving you a demonstration. Saltwater in ocean and saltwater in lakes. Only about 3% is fresh water. So out of this whole cup, just this little teeny tiny top is fresh water that we can use. So we have 26% lakes, 30% groundwater, 69% is all that ice, and then 4% is water vapor. So on page 329, rivers and lakes. Figure 2, all the rivers and lakes marked on the map contain fresh water, as do many other smaller rivers and lakes. North America's 5 Great Lakes, which surround us, contain about 20% of all the water in the world's freshwater lakes. We are so lucky to have those by us. Groundwater. To find some of the fresh water on Earth, you have to look underground. When it rains or snows, most water that doesn't evaporate soaks into the ground. This water trickles through the spaces between particles of soil and rock. We'll learn more about that in the next chapter. Water that fills the cracks and spaces in the ground soil and rocks is called groundwater. Far more fresh water is located underground than in all of Earth's rivers and lakes. That's interesting fact. Page 330. These are our last 2 pages. What is the water cycle? You probably learned about this in 1st grade. Earth has its own built-in water cycle system, the water cycle. The water cycle is a continuous process by which water moves from Earth's surface to the atmosphere and back, driven by energy from the sun and gravity. In the water cycle, water moves between the land, living things, bodies of water, and Earth's surface and the atmosphere. We'll play some videos later on this week about the water cycle. Water evaporates. Where does the water in a puddle go when it disappears? It evaporates. It's becoming water vapor. Evaporation is the process by which molecules at the surface of the liquid absorb enough energy to change to a gaseous state. Water constantly evaporates from the surface of bodies of water, such as oceans and lakes, as well as from soil and your skin. Plants play a role too in the step of the water cycle. Plants draw in water from the soil through the roots. Eventually, the water is given off through the leaves as water vapor in a process called transpiration. So you're at the beach, you drink a lot of water, and then all of a sudden you're like, oh my gosh, I'm so thirsty again. Because all that water, the sun evaporated that water, it had some transpiration, so it evaporated that water from your body. Plants also do the same thing. As much water as they drink, the sun is actually pulling it away from them also. And if you have a swimming pool and you notice on the hotter days, the water level gets a little lower, that's because the sun pulls that water and evaporates that as well. Page 331. Condensation forms clouds. So after the water molecules evaporate, so they get pulled up into the clouds, warm air can carry the water molecules all the way up. Air tends to become colder as it rises. Water vapor condenses more easily at lower temperatures. So the particles join back together. So some water vapor cools and condenses into liquid water. Droplets of liquid water clump around solid particles in the air, forming clouds. So the water vapor joins with the particles in the sky and you get clouds. Those clouds fill up and then water falls as precipitation. As more water vapor condenses, the water droplets grow larger. Eventually, they become so heavy that they fall out of the sky and back to Earth. Water that falls to Earth as rain, snow, hail, or sleet is called precipitation. Most precipitation falls directly into the ocean. Of the precipitation that falls on land, most evaporates. A small amount of the remaining water runs off the surface into the streams and lakes and is processed in a process called runoff. But most of it seeps into ground. After a long time, this groundwater may flow down to the ocean and evaporate again. Precipitation is the source of almost all fresh water on and below Earth's surface. For millions of years, the total amount of water cycling through the Earth system has remained fairly constant. The rates of evaporation and precipitation, they are balanced. So we're not losing or gaining any extra water. That is it for this lesson.